So we're going to continue on with this pattern of exploring the exponent law. So what did we say that we have to do when it comes to a cubed divided by a? So if I'm going to expand and simplify, that's going to be a. It's going to be a times a times a over a. Simplifies. So that's going to be a squared, right? So that's going to be a squared, and if I'm going to use the exponent law, what do I do with the exponents? I minus them. So 3 minus 1, which is a squared. So basically, the first example you need to expand. You're going to write your answer from the expanded and simplified form in the second one. With the exponent law, I am going to just use the exponent law, okay? Because I'm going to compare at the end. Okay, what do I do if I have a to the power of 3 divided by a to the power of 2? So that's a times a times a divided by a times a. Simplify, simplify, what are you left with? A. If I do this, the exponent law, so 3 minus 2, that gives me a to the power of 1, or a is the same thing. Do we understand what we're doing? Okay. Now, a to the power of 3 divided by a to the power of 3. So times a times a over a times a times a. Simplify, simplify, simplify. What are you left with? So if I have 3 chocolate bars and I'm dividing them on 3 people, you each get 0? You each get 1. Whenever you divide something by itself, what's your answer? 1. You're dividing a cube by a cube. Yes? It's 1. You have 3 chocolate bars. There's 3 of you. You each get 1. So the answer here is 1. Not a. It's 1. Anything divided by itself is 1. A letter, a number is 1. How about a cube? So if I do the exponent law, so that's 3 minus 3. What's 3 minus 3? So a to the power of 0. We're going to talk about this. Do you see, is this answer and this answer the same? No. They're not the same. Technically. We're going to talk more about it later. Can you do me a favor? On your calculator, give me a value for a. Give me any number for a. 23. Put 23 to the power of 0. What do you get? Give me another value for a.
30.
Put 30 to the power of 0. What do you get? How about if a is 1,000? Put 1,000 to the power of 0. What do you get?
1.
So anything to the power of 0 is?
1.
And that's why this is 1 and this is a to the power of 0. They are the same. It's just they're written differently, okay? So anything to the power of 0 equals to? All right, now let's see how we're going to simplify this. I have a times a times a over a times a times a times a. Okay? Eyes on me, please. Cancel, cancel, cancel. What do I have left? Where? In the denominator, right? So this is going to be 1 over a, because there's nothing left on the top, so that's 1, and then the a is left in the denominator. So this is the question that you were asking me. What happens if my first exponent is smaller than the second exponent? Now, if I'm going to use the exponent law, what am I going to get? 3 take away 4. What's 3 take away 4? -1. So that's a to the power of -1. They don't look the same, do they? But we're going to figure out why and how can I make them the same. What does it mean to have a negative exponent? We haven't seen negative exponents yet. What does it mean to have a negative exponent? This one we've already done. Just scratch this one. Let's look at a to the power of 3. This one we've already done too. What do I do here? So a times a times a over a times a times a times a times a. Let's cancel. So 1, 2, 3. What do I have? So 2. Okay, so what's left? 1 over a squared. It's not 2. It's 1 over a squared. All right, let's do the exponent law. So a, 3 take away 5. What's 3 take away 5? -2. Okay, so cancel, 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 cancel. What do I have left? 1 over a cubed. If I do the subtraction, 3 take away 6, so that's a to the power of -3. Have you noticed any pattern here? Have you noticed any pattern?
Yeah, the same exponent.
Same exponent, but if it's negative, it's on the top, and if it's positive, it's on the bottom. Let's see. So, a times a times a all over a times a times a times a times a. I can cancel. And I'm left with 1 over a to the power of 4. If I subtract, I get a to the power of -4. So, here's the rule. If you have a negative exponent, then you are going to flip your base and you're going to make your exponent positive. So, let's look at this. A to the power of -4. What's the flip of a? What is a divided by? 1. Right? Anything that there's no division, it's 1. Right? Okay. If I flip it, what does it become? 1 over a. And then I make my exponent positive, so that becomes +4. Yes? So, when I had a to the power of -4, it's 1 over a to the power of 4. Now, what if I have a to the power of -3? Flip it, so that's 1 over a to the power of 3. So anytime you have a negative exponent, you flip the base and you make your exponent positive. Let's look at this. Let's say if I have a over b to the power of negative 3. What would the flip be? B over A to the power of 3. Okay? So to make, you can't leave your answer with a negative exponent. It's not acceptable to leave your answer with a negative exponent. If your answer at the end has a negative exponent, whatever has the negative exponent, you want to bring it down to the other spot. Right? So, for example, if I have this, A negative 3 over B 2. Okay? Eyes on me for a second, please. So, in this case, only A is raised to the negative exponent, right? B is a B2. It's a positive exponent. So what I have to do to make this positive is I have to bring this whole thing down to the denominator. So that becomes 1 over B squared A cubed. So you change where it is. If it's in the numerator, you put it down in the denominator. If it's in the denominator, you put it up in the numerator, and you make it the opposite, the positive exponent. Okay? The rule says if you have A, I'll write the rule on the next page. So the important part is you understand you can't leave your answer with a negative exponent. So here's the two rules that we learned here. Any base to the power of 0 is equal to what?
1.
Is equal to 1. So a to the power of 0 is 1. 10 to the power of 0 is 1. 500 to the power of 0 is 1. Anything, a letter or a number to the power of 0 is 1. Okay, so in this case, it's x2 minus 2, so that's x to the power of 0, that's 1. If I do this, 2, 3 minus 3, so that's 2 to the power of 0, that's 1. 5, 4 minus 4, that's 5 to the power of 0, that's 1. Anything to the power of 0 is 1. Division law is when you subtract your exponent. We're going to write the last law, which is the negative exponent law. So, the negative exponent law, don't flip until the end. That's the most important thing. Okay? Can I go to the next one? Unless you have a big thing here with a negative 3, let's say, then flip first. If your exponent, the negative exponent is on the outside, then you can flip first, that's fine. Otherwise, leave the flipping till the end. Simplify, then whatever is negative, you flip it. Okay? So, apply this one last. Again, as I said, unless you have it on the outside, like let's say if you have 2x squared y 3, 4x negative 2y 9, let's say you have this, okay, then probably what I would do first is I would flip here first. Again, sometimes you don't want to do this until the end, but the important part is don't leave. You can't distribute that negative in. It's going to make a mess, okay? So maybe right here, I would flip first, and I bring whatever is the denominator to the numerator, and then whatever is the numerator to the denominator. Okay? Then I simplify my inside, then I bring my 3 in. Okay? We'll talk more about something like this in a second. So, apply this law last. Take only the base with negative power and switch its placement. So basically numerator to denominator and vice versa, and make your power to positive.
Sorry, I need it.
Which one? Placement?
Yeah,
Placement. Yeah. Power to positive. Vice versa. What? And change power to positive. Okay, do you have a minute to do that question on the top? So, what did we do first? Because everything is the power of a negative, I switched numerator and denominator and made it positive, right? Okay. Then what do you want to do first? Simplify inside the bracket first, right? So if I'm going to simplify inside the bracket, I'm going to have to take each one separately. So I have to divide 4 by 2. What's 4 divided by 2? 2. What do I do with the exponents here since I'm dividing?
Is that exponent negative 2?
Yes, I'm not going to change this until the end, remember? I have to subtract. Negative 2 take away 2 is what? Negative 2 take away 2. Negative 2 take away 2. What is that?
0. So 1.
It's negative 4. It's negative 4. Then if I do this, that's 9, take away 3, so that's 6. I still have that power of 3 here. Are we okay with that so far? Then, if I have a power on the outside, what does it say I have to do? Distribute that 3, everything inside. So that's 2 to the power of 1 here, yes? So it's going to be 2 to the power of 3. X to the power of negative 12. Y to the power of 18. Now, is this my final answer? Okay, what would be my final answer? 8 x to the power of negative 12 y to the power of 18. Is that my most simple form? Can I do any more simplification? I can't, right? Now, question to you guys. My final answer has a what in it? A negative what? A negative exponent. Can I have a negative exponent in my final answer? So this is where you apply this law last. Now, because my final answer has a negative, I want to bring it from the numerator to the denominator to become positive, and that becomes y to the power of 18. That stays the y to the power of 18. This is the most complicated it's going to get. Okay? So, I'm going to recap of the steps that I've taken here. So, the first step I took is because my outside exponent is negative, I want to just make it positive because then it's easier for me to multiply that 3 in. Okay? So, I flip my numerator and denominator, and I made my exponent positive 3. Is that a good step for you? Do you understand that part? Then, I took my coefficient and I simplified. 4 divided by 2 gives me 2. Then the x's, because there's division, I subtracted my exponent. So negative 2 take away 2 is negative 4. Kept the base, negative 4. Then, y to the power of 9 and 1 to the power of 3. Kept the base, subtracted the exponent. 9 take away 3 is 6. Are we okay with this? Then, I distributed that exponent in. So I multiply the exponent by the exponent. So 3 times 1 gives me 2 to the power of 3. 3 times negative 4, that gives me x to the power of negative 12. 3 to the power of 6, that gives me y to the power of 18. 2 to the power of 3 we know is 8, so we simplify that. Then the last step is because x has a negative exponent, I want to switch its position. Right? So if it's in the numerator, you bring it to the denominator. And vice versa if it was in the denominator.
What does that say below the
This one?
up in your example?
Yeah, where?
Up y.
Y cube?
Yeah, y. What is that? Y
Power 3.
power 3.
Yeah. Are we okay with this?